Okay, can everyone hear me? Send me a message on chat box. Okay, so at the last class, we did 20th question, right? 20? Was that the 20th question we discussed at the last class? What's the question number we discussed at the last class? Okay, right. Then try 20 first question. Try 20 first. I'll give you a minute, then I'll discuss. Try 21. Let me know the answer. Okay, let's see. So we have 2 kilogram mass. Force is applied 10 Newton. It is on a horizontal smooth plane. Inclination is 60 degrees. So then they say it is moved 3 meters. 3 meters. Initially it is at rest. So what they ask is final velocity. Final velocity. So how do we find that? So this is a smooth plane, right? Meaning there's no friction. So you don't have to do work against friction. The work you do converts into the kinetic energy gained. That's what happens. So we can say work done equals kinetic energy gained. So when you apply a force, this gets to acceleration, then that work converts into kinetic energy. There's no any other energy types. This is elevation does not change, right? So there cannot be a potential energy. So what happens is kinetic energy increases. Okay, so what is the work done? Force is to the direction of displacement. Force is 10 cos 60. Cos 60, right? Times 3 equals kinetic energy gained. Here the kinetic energy is half mv squared. Initially it is at rest. Kinetic energy 0. So using this you can find velocity. No, they are kinetic energy, right? So you can just say Ke. Ke gained. So what do we get? 15 joule. Third one, right? Not the fourth one. Yeah, answer is third one. Understood? Right. Then try the next one. Give you a minute. 22. Right. So masses M and simple M and capital M are pulled by the same force to the same distance. Displacement. They are kinetic energies. Okay, let's see. Ratio between their kinetic energy. So in both cases, what's the thing? What's the work done here? Fx. Here work done, it also Fx. Understood? So kinetic energy gained is equal to work done, right? So do you understand kinetic energy in both cases is the same? Do you understand that? Because work done at both cases is the same. So kinetic energy gain also same. Ke and K is same. So what's the ratio between them? 1:1, right? Fifth one. Do you understand that? Right. Then try 23rd. 23rd. Then they ask 23rd, ratio between speeds in the question. Kinetic energies are the same, but think about speeds. What could be the answer? Quickly let me know. Okay, so kinetic energies are the same, meaning half. First one is simple m. Let's say first one is simple m. Is it given simple m or capital M first? Yeah, simple m is given. So you have to take into that order, right? First case is simple m. Simple m v1 squared equals half capital M v2 squared. Kinetic energies are same, but the velocities are not same, right? Because they have different masses. v2 squared equals m divided by simple m. Then take the root. Capital M over simple m half. It's the velocity. So the answer should be, yeah, correct. Fourth one is the answer. Correct, right? Then try next one. Then they are asking about momentum. Try that. 24. Ratio between momentums. Okay, let's see. So momentum of first divided by momentum of second, right? So momentum of first is mass times v1 divided by momentum of second mass times v2. Say they ask this ratio in terms of mass, right? So we already know v1 divided by v2. Then just substitute that. So v1 divided by v2, that is capital M divided by simple M half. So what do you get? Simple M divided by capital M half. Third one, yeah, correct. Third one, right? Farus. Uh, Farus, do you understand? Okay. Okay, then try next one, 25. two masses with mass ratio. Let's say one is m, other one is 2m. Two forces, 2 to 1, right? 2 is to 1, so 2f to the same displacement. They're asking about ratio between their velocities. Let's say velocities are v1 and v2. So work done is equal to kinetic energy gained. Okay, let's see. Here the work done, right? 2fx equals kinetic energy gains. Second case, work done is fx equals kinetic energy gain. But the mass is 2m, right? So, yeah. Then you just have to find the ratio. Velocity ratio or the speeds ratio. Just divide. Half cancels off. Fx cancels off. 2 equals m cancels off 1 over 2. v1 squared, v2 squared. So it goes to the other side. 4 equals v1 squared divided by v2 squared. Take the root of that. It becomes 2, right? So the answer should be 2 is to 1. Yeah, correct. First one. Understood? So the purpose of this question is to show you that work done is equal to kinetic energy gained. Since this doesn't have friction or difference of elevation, so what happens? So what happens here? Masses are different. Likewise, you can take that. So directly work done is equal to the energy gained there. That work done is converted into the energy gained. So that's the purpose of these questions, right? Then try, so each question is to clear out a theory part on energy, right? So that theory part you must understand. Next one, next try 26. Give you a minute, try that. Let me know the answer, right? These are simple questions. Here also work done is equal to kinetic energy gained. It is not kinetic energy, it is kinetic energy gained, right? Difference of kinetic energy. Okay, let's see. So initially, here you cannot say because it is the same amount of speed. Increase of speed is same in both cases. But what happens to the kinetic energy? To increase another V at the second case, you need 3 times the kinetic energy. Understood? So here at the first case, kinetic energy gained is half mv squared minus 0. Initially at 0, then half mv squared. Second case, let's say energy is work required is E dash. At the second case, what's happened? Speed is doubled. But when speed gets doubled, due to v squared, it gets 4 times, right? Minus half mv squared. So the speed is increased from v to 2v. So what do you get? 4 minus 1 m 3v squared. 3v squared means half mv squared is e, right? So it is E dash is. At the second case, we need 3 times the kinetic energy. So it is not same, right? Answer is the third one, right? Got it? Got it, right? You need 3 times, not just 1. You need 3 times the kinetic energy at the second case. So those things you have to understand, right? Velocity is increased by just v, but the work required or the energy required is 3 times at the second case. Those are special cases, right? Right, then try next one, 27. Right, let's see. So we have a ladder. Initially the ladder is horizontal. It is horizontal. Stand up means you have to make it vertical. So when you make it vertical, what changes? If potential energy equals 0 here, this line, this ladder has a 0 potential energy in this case. This ladder has what? You have to consider when you get a lengthy object with dimensions, in order to find the potential energy, you need to consider its center of gravity. You have to think about the elevation of or the lowering of the center of gravity for a object which has lengths. So you can consider that whole object to be a point object. You just have to think about this point. All the mass is contained in this point, center of gravity. So it is elevated by L over 2. So what is that? mg height is L over 2. So this is the increase of potential energy. So this amount of potential energy must be given by work. This is the least amount of potential energy, work required. When you give this amount of work, that converts into the potential energy. So that is the equation, that work converting into potential energy, right? So the answer is what? Second one, right? Okay, correct. Faros, did you understand that? Okay. Then try next one, 28. It is a bit complicated. Just try that. I'll give you like 2 minutes. Okay, now listen, right? Listen. So this is one case. You have to make that, you have to pull that and get the chain onto the table like this. What do you have to do? What they ask is work required, minimum work required. So to find that, the thing is when you think about these two cases, potential energy is different. So that difference of potential energy should be the work required. If this is considered P equals 0, this level is considered P equals 0 level, right? So potential energy here is 0. Okay. So what you have to do is you have to find the potential energy here. How do we do that? So in order to find that, you have to find the center of gravity in this case. Center of gravity in this case is at here, but here for the whole object, you have to find the center of gravity, position of center of gravity. So we know that this part is L over N, right? L times 1 over N, L over N. So this part should be what? L minus L over N. Total length is L, so you have to subtract L over N. So you get this one. Let's say mass of this is simple M, mass of this is capital M. I'll take it as like that, right? Because then it will be easier. So this is at the middle of this part, simple M. This center of gravity is at the middle of this hanging part. Right. So the center of gravity of the object should be where? Should be along this line, right? So to which ratio does it share? To the inverse ratio. So to this side it is capital M, to this side it is simple M. Then you can draw a triangle like this. Then draw a horizontal line. So this is what you get here. This triangle, right? So we have G1 and G2. This is G1, G2. And center of gravity of the object, compound object is at G. Then I draw this horizontal line. What I need is this length. This length. So this is where the center of gravity is below this much. So you can find simple X. When you lift this much, when you take the center of gravity, in order to make this, you have to move this center of gravity to here. Yeah, exactly at the center, yeah. If they don't say anything, this is a uniform chain, right? So it is exactly at the center. So what is this length? This length is this one, right? Total length is L over N. So you have to divide it by 2. So this length is L 2N. This length is what? Half of this length. So what do we get? 1 over 2 L minus L over N. This length, this total length. Then this ratio. What is this ratio? G1 to G ratio is simple capital M. This ratio is simple M. So we have capital M to simple M. Let's say this point is A and this point is B. So G1 to G to G2, G to G2 is equal to capital M to simple M. If you think about similar triangles, these two are similar triangles, right? This one and this is small one. They have the same angle, so they are called similar triangles. So if this is the ratio capital M to simple M, here also ratio should be capital M to simple M. So AB to BG2 is capital M to simple M. Capital M to simple M. Same ratio because of similar triangles. Right? Then what do we need? We need X. So X is equal to what? Here the total length is L over 2N times. So what's the ratio? Capital M to simple M. Just add capital M plus simple M, and from here this part is capital M. Then you have to simplify these. So what is capital M? Capital M is the mass of this hanging part, right? Hanging part is capital M. So how do we find that? We can just mention that capital M as L over 2N. You can show the mass of this part as a length. Got it? Length, actually you have to multiply by cross section and density. I'll just multiply cross section of the string, then you get the volume, then density, but this cancels off, right? Then again capital M. Simple M is what? This length. Arrow. So arrow cancels off. This capital L also cancels off if you want. So above it is 1 over 2n. Below 1 over 2n plus 1 minus 1 over n. All the L terms, I got rid of those, right? Then you just have to simplify this. L over 2n times 1 over 2n. If you simplify below, what happens? 1, just take 2n as the common denominator. 1 plus 2n minus 2. Then here 2n cancels off. 2n times 2n minus 1. Is there an error there? It is L over n, right? Not 2n. Capital M is L over n. Here also L over n. Okay, the rest is okay. 1 over n. Then 1 over n minus 1 over n cancels off. What do you get? L over 2n times, everything cancels off, 1 over n. So what do you get? L over 2n squared. So this is the value of x, right? L over 2n squared. Okay. Just take it down. Right. So the total length is capital L, right? So the goal here is to find this simple x, this height. That is what we need. This is the position of center of gravity of this object. So we need to find how much is it lower than this level. So that is x. That is what you need to find. So I just enlarge this triangle in order to find x. Okay. G1 is center of gravity here. So it has a mass simple m. I just put it as simple m because mass of the hanging part is capital M. I just took like that, right? I think it is easier if I just okay. So mass of this part I took it as simple M, right? This part I take it as capital M, right? Then center of gravity here is G2, center of gravity here is G1, each part. Then what happens? So you have two parts, right? Compound object. So the total mass is capital M plus simple M. But what you need is this center of gravity. How do you find that? So do you remember if I draw this triangle, right? Draw this triangle. This point has a mass simple M. This point has a mass capital M. So if you have so this whole thing is reduced to a simple M and capital M 2-point masses. So you know the ratio for the center of gravity should be capital M to simple M, right? Know that? Inversely proportional. These lengths, you know that, right? These lengths, it is inverse. Capital M to simple M. This is capital M, this is simple M. Okay. So what we need is to find this x. X means the center of gravity. How much is it below vertically? Once you find this one, you can find the potential energy required. So this is simple x. X is what you need to find. Right. So this ratio, I'll just simplify this ratio first, right? Capital M to simple M. I'll just divide that. Capital M divided by simple M. So what is capital M? This hanging part is capital M. Length of that hanging part is L over N, right? L over N is the length of that capital. Then multiply that by cross section. When you multiply that by cross section, this length is multiplied by cross section, you get the volume. Volume multiplied by the density. Then simple M. Simple M is this part. So what's the total length of that part? L. I'll take L out, right? So you get 1 minus 1 over N. That also same cross section multiplied by density. So what do you get? A rho cancels off, L cancels off. You get 1 over N divided by 1 minus 1 over N. So 1 over N divided by, take the common denominator, you get N minus 1. Then this N and N cancels off. So the ratio between capital M and simple M is 1 over N minus 1. Did you understand this ratio? That ratio you need to find first. Up to here, take it down. Up to here. And thumbs up once you're taking it down. First find this capital M to simple M ratio. 1 over n minus 1. Thumbs up if you are done. Farus? Okay, take it down. Right. So we found that, right? So that is the first step. Capital M over simple m. So that is 1 over n minus 1. Right? Okay. Now what do we do? We need to find this simple x. How do we do that? Do you understand? If this ratio, capital M to simple M is this ratio, then this ratio also should be capital M to simple m. Because similar triangles, right? These triangles has the same. This large triangle and small triangle, they have the same angles. So this ratio, capital M to simple m, should be capital M to simple m ratio. Then you can find x. So what is x? Total length here. So what is this length? This length is half of L over n. This is L over 2n. You understand that? This length is total length L over n, but triangle is at the center. So it is L over 2n. Total length is L over 2n. From L over 2n, the ratio is capital M to simple m. Then what do you get? You have to add the ratio. Then you need to get the length related to capital M. This is what you need. Got it? Understood? Right. Then what do we do? Just divide this one and this one in order to make capital M over simple m, or else you can do like this. According to this one, capital M is equal to what? No. If you cross multiply, simple m is equal to capital M times n minus 1. Cross multiply, simple m is equal to capital M times n minus 1. So we can keep capital M. Instead of simple m, I am substituting this. Plus capital M. So L over 2n times, you can take capital M out. Inside, we get n minus 1 plus 1. Minus 1 plus 1 cancels off. M cancels off. L over you get a simple n remaining here. 2n, it gets squared. So this is x. Take it down. Previously it looked complicated because I did two things at the same place, right? So this looks less complicated because I did this at two places in two steps. So did you understand how I took x? Thumbs up once you taken it down, right? Taken it down? Thumbs up, right? So you have to do work. You have to do work. So this is below this amount, L over 2n squared amount. Center of gravity is below. So you have to do work in order to lift that upwards. So how much? So this is the height you have to lift. Then the potential energy difference should be mg L divided by 2n squared. Here the potential energy is 0. So this is the work required, mg x. Take it down and thumbs up once you are taking it down, right? Okay. Uh, then different set of equations, I mean different cases, 29th question. So in the 29th question, you get something about resistive forces, right? First try that, then I'll explain. Try that first, 29. Give you a minute. Right. Let's see. So that's a simple question. We have a target, right? Target does not move, it is a static target. So a bullet comes and hits the target. So what they ask is velocity that it hits the target. It penetrates this 8 centimeter distance, right? Then inside it stops. So here what has happened? The bullet had kinetic energy. That kinetic energy is completely lost when it comes to here. Why is that? You know, there's a resistive force while this is penetrating this target. There's a resistive force acting on the bullet. So what does this resistive force do? Resistive force does work on the bullet against the motion of the bullet. So that's what resistive force means, right? So once the work done by the resistive force match with the kinetic energy bullet had, then bullet stops. So the work done by resistive force match with kinetic energy, actually kinetic energy difference, but I'll take here because it stops, I can take it as kinetic energy minus 0, right? This is the change of kinetic energy. So here the energy conversion is like this: work done by resistive force equals kinetic energy loss. You can take it down. Work done by resistive force equals kinetic energy loss. There now the kinetic energy loses. Before previous questions, you provide a force, then it gains the kinetic energy. But when you apply resistive force, kinetic energy loses. But in both cases, the magnitudes are the same. Then you just have to do a substitution to find this v squared. Final velocity 0, initial velocity is v. Here u, right? I took it as u. Okay, do the substitution. Force 100, 8 centimeters. Convert into meters. Half mass is 10 gram. Kilogram u squared. Two times 8, 1600. So you get 40. Third one, right? Meters per second. Faros, did you take it? 40 meters per second. Understood? Okay. Then try next one and let me know the answer. 30. Second one. Right. So what they ask is factor of change, right? So you don't have to solve this again. According to this equation, work done by resistive force equals kinetic energy loss. So what do they say? According to this one, we are keeping, at the second case, right? We are keeping same 100. So force is a constant. Force is a constant. This is how you do MCQs, okay? You don't have to solve again. At the second case also, force is constant. Mass does not change. Half is obviously constant. Then what can you get? that penetrating distance is proportional to what? U squared. So they say this initial velocity is doubled. Doubled is squared, then S should be 4 times. Second one. Yes, correct. Farouz, did you understand that? Right. So this is how you do MCQs, right? You have to use proportionalities. You can do the question again and find the new displacement. But that's not the way, right? Because you need to save time there. As much as possible, you have to use these proportionalities, right? Get used to that. Right. Then try 31. Next one. Bus moving at 20 kilometers per hour stops under a constant resistive force. Moving distance is S. It is a similar question, right? So for this also, work done by resistive force is equal to half mv squared. Here, initial velocity 20, then it applies brakes. Brakes acts as the resistive force. That is capital F. At the second case also, bus stops at a S distance. So S is a constant. You have to understand that S is a constant here. Got it? Otherwise, these are complicated questions, right? Same distance. Then what do you get? Half m is force is, now the force is proportional to V squared. Yeah. Okay. So what should be the force? Farus? Force should be? Do you understand? Force should be 4 times 4F. Fifth one, right? So for these questions, you don't have to do unnecessary calculations. When you compare two cases, you can use these proportionalities, right? You get rid of constants. Yeah. Yeah, what's the matter? Okay, right. Sure. Right. Then try 32. 32. For 30 second as well, you can use proportionalities. Okay. Okay, let me know the answer. Okay, here also kinetic energy is enough to penetrate just a one, right? One Planck. So what they ask is required speed if you have 3 Plancks together. So the distance it has to travel is, if this is x, this is 3x. So they ask the initial speed required at the second case. So here also mass of the bullet does not change. Resistive force is the same, right? They don't say anything about same Planck, so we have the same resistive force. Actually, it should be mentioned that resistive force is constant. So V square is proportional to S. This is the equation you have to use. V squared is proportional to S. Okay, so at the first case, you get root 3 squared is x. You have to find it for the second case velocity. Let's say v. V square is proportional to 3x. Then just divide. Root 3 square is 3. 3. V square is 9, so V should be 3 meters per second. Second one, right? Take it down. Did everyone understood? Okay. So that is the proportionality there. V square is proportional to x. Okay. Okay, then try next one, 33. Just write this equation, then think about variables and get rid of constants. You don't have to do any unit conversions, those stuff as well, right? It gets simpler. You don't have to do any unnecessary calculations when you are using proportionalities. Root 3 squared. I just, so this is second one, this is first proportionality. I just divide second by first one. Second proportionality by first one. So root 3 squared means 3, right? So you get v squared divided by 3. 3x divided by x, 3. Okay? Understood? Right. Okay, try 33. I'll give you a minute. Try that. 33. You must get used to these proportionalities, right? It doesn't matter how many times. Get used to proportionalities, okay? Without that, it is not possible to go for an A. You must be able to do these proportionalities. So the same equation. All the objects stops at the end, right? So you can use half mv squared. So since you are using proportionalities, you don't have to you do unit conversions as well, okay? You have to practice for doing these difficult questions as well, right? So that's the only way you can develop. Did you get an answer? Let me know. Okay, we'll see. So when you compare these two cases, same mass, right? Mass does not change. You can get rid of mass. Half you don't need. So what changes when you think about two cases? Force changes, displacement changes, and it is proportional to v squared. There are three variables. Okay? Then apply this proportionally to the first case. So at the first case, what happens? Moving at 4 square. Resistive force 5. Moves the displacement 20. So this is the first proportionality or the first case. At the second case, initial velocity 8. Resistive force 10. So what they ask is S, let's say S dash. This is the second proportionality. Okay. Then you have to divide second by first. So 10s divided by 5 times 20 is 100. Second divided by first one, right? So this is 8 squared divided by 4 squared. 10 cancels off. S divided by 10 equals 64 divided by 16. You get 4, right? Yeah. 40 meters. Correct. Sorry, 40 centimeters, right? 40, it should be 40 centimeters because we substituted centimeters and didn't convert units, so it should be 40 centimeters, okay? Then try 34. 34. So for all these questions, the resistive force is constant. Usually it is not constant, right? But in this lesson, resistive force, we have to take it as constant. Let me know the answer. A bullet inside a target penetrates distance of 15 centimeters. And its speed is dropped by 50%, meaning if it hits at u, now the velocity is 50% means half, right? So the remaining velocity is u over 2. Then somewhere here it stops. Further distance it moves. So what they ask is this x. So what's the equation here? Fs, work done by resistive force, is equal to change of kinetic energy, right? Here you have to consider the change of kinetic energy because there's a velocity at two cases. 7.5 centimeters. Okay, let's see. So the first case is this one, right? This is the first case. Then you have second case. Second case is from here to here. Okay, for the first case, force is the same, right? Resistive force does not change. Force times 15 equals delta Ke, change of kinetic energy. So what is the kinetic energy here? Half mu squared minus half m u over 2 squared. I'll just simplify this further. Half mu squared, take half mu squared from both. You get 1 minus, here it is 1 over 2 squared, right? 1/4. 1 over 2 squared means 1/4. So 4 minus 1, 3 over 4. So F times 15 equals this one. This is change of kinetic energy. That's why I had to do the calculation, right? Then for the second case also, it is F. The distance traveled is x from here to here. Okay. So what's the kinetic energy here? Half m u over 2 squared, meaning u squared over 4. Final kinetic energy is 0. So the change 0 it is. Then what do you do? So this is the first equation, second equation. So these are equations, right? Divide second by first. Doesn't matter which one which. So FF cancels off when you divide it. You get x divided by 15. This half mu squared cancels off, and also this 4. So you get 1 over 3. X is 5 centimeters, okay? Isn't that? 5 centimeter. This should be less. Remember that 3 times at the second case, it is 3 times. Now it is 3 times less. So the answer should be 5 centimeters. Correct that, right? At the second case also, it cannot be 15 centimeters. Remember, when you accelerate on a vehicle, to move from 0 to u, you need e. But that the second, when you have to increase the velocity by the same amount, but you need 3 times the energy. Here you need 3 times less energy. Or else you can just do this calculation, right? Okay. Then try next one, 35. 35. For that one, you can use a proportionality. Let me know the answer if you get it. So kinetic energy of the bus, final kinetic energy is 0. So changes can be considered as half mv squared. work done by retardation force. It is resistive force, right? Retardation means. So you can use this equation. Get rid of constants. Retardation force is constant, right? They don't say it is changes, so it is constant. So here mass changes, right? Only the mass changes. All the conditions are same. All the other conditions are same. In the question they say. Okay, let's see. All the conditions are same, right? Only the mass change. Velocity also, initial velocity also same. So mass is proportional to s here. So if at the first case mass is simple m, distance traveled is s. Second case increases by 50%. Now the mass is 1.5 m. Let's say s dash. S dash divided by s equals 1.5 m divided by m. 1.5. So s dash is what? 1.5 s. 3. 0.5 is increased, right? So you have to add 1 plus 0.5 to get the new mass. Mass has to increase, right? Not decrease. Understood? Right. So these are very important concepts, right? You have to clearly understand these, right? Okay, then try 37. 37. Do we have an answer? Okay, listen to this, right? This one, to get the kinetic energy, listen, right? You have half mv squared. Okay, so okay, let's see. You have half mv squared. There's another equation you have to remember, right? At the last class as well, I told you, I think, you just have to multiply this by both the numerator and denominator by simple m. So you have m squared v squared divided by m. So what is this? mv squared divided by m. K is equal half mv squared divided by mv squared is what? Uh, Momentum, right? P. So P squared divided by 2m. This equation also it is better to remember, right? If you don't remember, you can quickly derive that. You just have to multiply by m and m, meaning 1, right? It doesn't change, equation doesn't change. So you can get kinetic energy in terms of mass and momentum, right? So here, what's the thing? So this is equal to work done by kinetic energy. So resistive force is F, moving distance is X. So what they ask is resistive force. P over 2m X. Fourth one, right? Yeah, fourth one. P squared over 2m X. You can remember this one, right? This will be useful when we are learning matter and radiation. That is the last unit. P squared over 2m. We'll be using this often, right? So you can use P squared over 2mx. So that is the resistive force. Take it down if you haven't taken. Then try 45th. 45th. Remaining ones you can try at home, right? Just try 45th. First draw is sketch. Now there's a friction as well, right? So the friction also do work. They ask friction, right? I'll just give you a minute. So this is somewhat different. Okay, let's see. Uh, see how the energy conversion happens here, right? Energy conversion happens. So here the object is given a kinetic energy by giving a 8 meters per second velocity. Given a kinetic energy. Do you see that object stops here, right? Why is that? This given kinetic energy is consumed by friction because friction acts opposes the motion, right? So this kinetic energy should be equal to work done by friction. Not only friction. What happens? Its height increases, meaning there's a potential energy increase as well. So this kinetic energy converts into work done by friction plus increase of potential energy. Got it? So do you understand the energy conversion there? Kinetic energy, as it moves up, keeps converting into potential energy. And also, another part of that kinetic energy is consumed by friction, work done by friction. So once these two match, the object stops. Understood, right? So that conversion you should be able to understand. Then you just have to do the simplification. Okay? Okay, let's see. So what they ask is F. So I'll keep substituting. V square is 80 squared. F distance is 4 plus mass is 1, 10. What is the height? 4 meters sine 30, right? Height is 4 meter times sine 30. This is the opposite side, sine 30. Sine 30 is half, 4 meter times 1 over 2. So it is 2 meters. So it is 64 divided by 2, 32. This is 20 minus 20 equals 4F. 12 divided by 4. So what do you get? 3 Newton. Second one, right? Correct that. Second one. Okay. Farooq, okay, is it okay? Right. Right. Then try next one, 46. 46. It is a similar question, right? It is actually the same questions. I mean similar. Uh, Only the values changes, right? Try 46 and let me know the answer. You just have to do a substitution there, right? Similar question. Done? So the height is S sine 30, right? This is the height. S sine 30. It is 30 degrees, right? Isn't that given? 46. Inclination 30 degrees to horizontal. At both cases, angle is the same. No, not 56. 46. Answer, did you get an answer? Okay. You just have to do the substitution for this equation, right? Okay, half mass is 2, velocity is what? 5. Velocity is 5, right? 25. 5 squared. Force friction is 2.5. Distance it traveled is s, right? That is what you need to find. Plus mass is 2, g10, h is what? S sine 30. Sine 30 means half. So this is s over 2. So 2 cancels off. This is 25 equals this cancels off. Then you get 12.5 s. 12.5 means 2 times 12.5 is 25, right? So what's the distance? 2 meters. Yeah, 2 meters. Then try 47, 47, 47, right? The mass of 1 kilogram is projected upwards at 6 meters per second. Average resistive force, it always opposes the motion, right? Is 2 Newton. Maximum height it reaches. So how does the energy conversion happen there? Here. So these types of question, there's a change of potential energy. So you need to have a P equals 0 line. PE equals 0 line. So kinetic energy is given, right? Kinetic energy is given. That kinetic energy, as it goes up, converts into what? Potential energy. Part of this kinetic energy converts into potential energy. Since it goes up, right? And its speed is decreasing. Another thing is, this resistive force also opposes the motion. So this kinetic energy is used. Okay, let's see. This kinetic energy, it's used as potential energy. Part of that is used as potential energy and other part as Fs, work done by resistive force. Okay, let's substitute 1, 6 squared, 1, 10. Height is what they ask. Plus force is 2. Here S is H. S is H. Understood? This resistive force acts for a 2 meter height, 2 meter distance. Okay, then simplify. 36 divided by 2, 18. 10H plus 2H, 12H. So what do you get? Just divide both sides by 6. You get 1.5 meters. Yeah, correct. So you get 1.5 meters. Okay. Right. So the next question also you have to do like this, then do this at home. Okay. Do the next question at home, and the remaining there are like 5 more questions just remaining. You can try them at home. Okay. Then we have efficiency and power. This part is not a complicated part, right? I'll give you a recording on this part, like on I'll give you a recording on efficiency and power part. You have to follow the recording, and there will be a separate set of questions for that, efficiency and power. So on the next week, I'm starting circular motion. So that is a new session, right? On next Saturday, 8 p.m., I am starting circular motion. Since we are running out of time and missed a few classes, so we'll start from circular motion at the next class at 8 p.m. But you must complete this one, right? Efficiency and power part. Okay. There are a good set of questions there. You have to follow those questions. Okay. Right. Then I'll see you on next Saturday, 8 p.m. With circular motion. Right. Okay. Good night.